Hello, my people out there. Una well done. This na Eduradio, your talk magazine program where they committed to inform you and enlighten you on our education for Nigeria with proper emphasis on the falling standard of our education, how our education, where our education, what our education be like. You like them? If you like them, so be it. But we for here. So far, well, the journey so far, I'm not going to say so good. But then, we meet her like this. Was that what you had? If not what you been get, toh. But no what me get. And I did hopeful, so it can be better. Eduradio, now we own. Eduradio, now our own. Today, let me be the team leader and your anchor person today. Again, my name now, Oman Dave. I not day alone. I do with my new tech people with the stream live. And as you sit down there, you want to watch us live, you fit go on Twitter at eduradio.ng. On YouTube, eduradio.ng. Make you watch us. Make you go for that click. Click like. Subscribe. Or share. The idea, the phone calls. Yesterday we opened our telephone, ring, last week, Tuesday. The calls when I get, in fact, up to this day, some would they tell them, say, we go come. We go open. They say they want to talk. Some say they appreciate them. Their children, they do well. Especially those when say that they public school, we don't afford data, that they get them. Eduradio. We been say we go, they bring in stakeholders. We go engage them with government. We can do better with our education. Ghana don't take a leap from this COVID-19. Did they do something? What are we doing in Nigeria? I propose severally, I don't talk I'm here. We get Federal Radio Corporation of Nigeria. Yeah, this Toyota Corolla in news. No, let me first. So I don't propose severally. With the FRC and what we get, Federal Radio Corporation of Nigeria, we can get over 36 state FMs. Before now, during the Jonathan administration, President Jonathan, they don't award contract for the construction and commissioning of community stations. Now voicemail. From what we know plenty. You get one senator or minister at that time, when get several licenses. It is Senate. This is an opportunity. Ghana don't use them. For those places where telephone network not very good, their radio, they don't improve on technology. Transit store radio, even Fulani man for inside bush farmer, get them. Why don't we implore? Our children, when their parents feel afford, I know how much I don't spend for data. Imagine the money. Some people, all they need now is feeding. But all we're talking about is refresher courses. Nigeria, which way forward? We can do better. But the yesterday that we are, or the tomorrow that we are hoping for, begins with the today. And the today begins with the input. You don't get nothing if you don't put something. We must work together. Last week, on Tuesday, we come here do a kind of overview of how the team B, education, the importance of education. We took you back to as far back as 1840 to 1842. How it took several years in between 73 and 15 years respectively, for them to top education, to take them up, because they said it was affecting their policies. That tells you that education is important. Now, it don't affect our educational system, sote. Even productivity don't affect, because you don't give what you don't have. That is why even face mask, when I come begin announce here, say no chemical we feed Duam. This is Nigerian made. You can make it. Make our local people make money. Even those kids within the wear, they can do it. But it all depends on our good education. We must serve our education. We must give premium, because the much money where they leave Nigerian shores, they're too much. The brain drain, it is said that over 23,000 African lecturers leave the shores of this continent out there for greener pasture. And out of that 23 million, well over half are Nigerian. And well over 300 students of this Nigerian origin, they leave, go there. That is huge capital flight on education. That money, imagine say been there here. Our health care, our education, up to say at least 20%. So that means it invariably implies that our infrastructures go there, bam. They go get morning, afternoon session. When one class for most public schools, they over 100 or 80. How many sessions you want to share them? They say when air blow, cock in it go show like this. I just pray we could get them right. If there's budgetary allocation where they equal to the population, it does what? It brings better results. But that has hampered us so much so that lecturers where they cry, yes, when I get on our own. But there have been series of cries and agreements, hues and cries. As far back as 1992, or between 1992 to 2017, lecturers alone don't go strike. Big freedom. 1997, what did they can't talk? 1999, sorry. What did they can't talk? They can't say they want higher allowance and to address this issue of brain drain or the rot we don't take place for education. Not be for good, but for good. The question is that government meet up, as if that's not enough. 2001, the matter complaint to you. Salary matter did there, and condition of service. Funding of university did there, review of the academic freedom and university autonomy. And one very important thing went strictly for that review, there was a clause. That clause been say after all of this, maybe they meet after 3 years. The idea that the kind of visitation panel was to check and take a critical look at the monies that have been released to you, either grants or otherwise, or allocation, it is well utilized. Government, they don't go. 2001, it was due for them to review in 2004. They don't go. 2005, they threatened strike. They can't send one negotiating team sometime 3rd of May. You know? They drag up to 2000. It didn't work. What I'm saying here is that, in fact, according to World Economic Forum, it said Nigeria are the 20th country with the lowest funding in education. According to statistics again, 262 million children and other adolescents, they out of school. Out of this number, 262 in the world, out of this whole number, they out of school. And out of this number, Nigeria now half. Why? Must we start from back? Can't we be pace setters? Giant of Africa, not be for mob. Now action. Here for Eduradio. If not be the COVID-19, when come metamorphose, come make us make we put down our review, where we go to bring una, where we go to organize seminars, workshop, to bring this into the fore, because our education must change. It must change. Our physics lecturer thereby, we don't lay down our own small. Make we use them again so that people wait on the lane, because we want to say we want scrap and we not do again. But series of calls where we get, due to popular demand, we know if we say, we'll open telephone line again today, but then we'll say make we allow our physics teacher, make he can't teach you now. Don't get physics. Because they called me, they appreciated him, and I appreciate all our teachers who don't teach. Our physics teacher, Mr. Vincent, you have the floor. Come give them what you did good at. You know, so you were tall like this.
Thank you very much, sir. I appreciate you for this rare privilege. Good evening, my people out there. Good evening, everyone. Good evening, my students out there. Those of you that are at home waiting to write exams, and good evening, Nigeria. My name is Bisala Vincent. I'm here to take you on a physics class. You're all welcome to Eduradio program once again. And today in this physics class, I'm going to be taking you on a topic known as elastic properties of solids. Elastic properties of solid is the topic, I repeat. Now, in this topic, because physics is generally studying natural phenomena. Physics studies natural phenomena. Therefore, there are different things that we see day to day are being studied in physics. Now, checking elastic properties of solids. The objective of this brief class we're going to be having includes one, you should be able to define elasticity. You should also be able to define what an elastic material is. You should also be able to state Hooke's law. And you should also be able to solve problems generally that involves Hooke's law. Now, I will start by way of introduction. What do you understand by elasticity? Elasticity is the ability or the tendency of a material to regain its shape after being stretched by a force or a load. I repeat, elasticity is the ability or tendency of a material to regain its shape, its original shape, after being stretched by a force or a load. What is an elastic material? An elastic material is that material that has a capacity to regain its shape after being stretched, as simple as it is. It is a material that has the capacity or the ability to retain or to go back to its shape after being stretched by a force or a load. That brings me urgently to what Hooke's law is all about, because that is a very key phenomenon in that topic known as elastic property of solids. Hooke's law generally states that provided the extension limit is not exceeded, the extension, which is labeled E, is directly proportional to the force or load applied. I repeat, Hooke's law states that provided the elastic limit is not exceeded, the extension E of an elastic material is directly proportional to the force or the load that is applied. That brings us to a little formula known as F is proportional to KE. Let me remove the K because I've not removed the proportionality symbol. This proportionality symbol can be removed, thereby allowing us to have F is equal to KE. This K in the formula here is known as elastic constant or stiffness of the material. All materials that have the ability to undergo elasticity have different elastic constants. Now, I would like to go further to explain another alternative measure of Hooke's law. Hooke's law can also be stated as stress is proportional to strain. That is, stress is directly proportional to strain. Now you have that like this. Stress is proportional to strain. If we remove this proportionality symbol, we will have stress to be equal to a gamma symbol like this, then your strain. Some books will tell you capital E is the constant there. This constant that I have put in here by removing that proportionality symbol is known as Young modulus, which is stress over strain at the end of the day. Now, Young modulus is stress over strain. Now, I'll briefly tell you what stress is. Stress is force per unit area, while strain is extension per unit length. I repeat, Young modulus is stress over strain, while stress is force per unit area, and strain is extension per unit length. I'm going to run down through the topic all through before we try to solve at least one or two questions. Now, let's consider work done by a spring. We're considering springs, we're considering rubber, any material that can be able to be stretched and then regain back its shape. That is what we're considering here. Now, considering the work done on a spring, you will apply a force on a string to stretch it definitely, and then it will regain back its shape. Now, if you apply a force, you believe me, if you try to use a catapult, for example, you will use an initial force. F, for example, there is an initial force. Let me use F1. There is an initial force. Then if you want to keep stretching that material, I believe you will also still increase the force, which will make you gain another force, F2. Now, the average of this force is taken into consideration when you are looking at work done by a spring. Now, you also have to multiply this average of the force by the extension of the material, meaning that you will have work done on an elastic material to be average of the force times E, which can be written this way. You might be seeing it this way if you have gone through this topic before. That is, work done on an elastic material is half Fe. Now this F is equal to Ke. Physics students or generally science students, you will observe that F is equal to Ke. By the time you put in this F is equal to Ke into this formula, you are producing another formula as well, which will be half is equal to K. Now we have Ke already, another E is here. By mathematics, of course, you should know that E times E is E squared. So you can have this formula to be written as W is equal to half Ke squared. Work done on a spring, don't forget, is equal to half Fe or half Ke squared. Now I have to make something very clear. In some question, you might be given that the average force that was applied on a body is equal to maybe 10 Newton, for example. You don't need to use this half once you hear the word the average force, because that means the force has been calculated and the average has been taken. So you don't need to use that half. We will solve a question that should tell us that majorly. Now, let me reverse a bit. Now, elasticity was what I defined first. I also defined what is an elastic material. I also stated Hooke's law. Now, in that Hooke's law, there's something I want you to note. Now, if you can plot a graph of extension against load, yes, any graph that gives you a straight line graph, when you plot extension against load of a material, if you have a straight line graph, that simply means that that material is obeying Hooke's law. Take note, any straight line graph of extension against load is known to be that the material is obeying Hooke's law. But by the time you have some curves in your graph, it simply means that the material did not undergo Hooke's law. Now, in this plotting of graph of extension against load, I would like to express on 3 terms briefly. There is something called proportionality limit on your graph of extension against load for a material that does not obey Hooke's law. Now, we have proportionality limit, we have extension elastic limit, we also have yield point, also have breaking point. Now, proportionality limit is that limit in which when a force is applied on a material, that material can easily regain back its shape, easily, fully to its original shape. But elastic limit is that point in which when it is exceeded, the material will not regain back its shape. Elastic limit is that point in which when the force continues to be applied, it will not regain its shape. While the yield point is that point in which the material will not regain back to shape. There is no point, there's no even an ability of the material to try to return at all. While the breaking point is that point in which the material will spoil, or if it's a rubber, it will cut. If it's a spring, it will break. Now, I have just explained proportionality limit, elastic limit, yield point, and breaking point. Proportionality limit is that point in which the material will regain back its shape fully. Elastic limit is the limit beyond which the material cannot regain its shape. If you stretch any material to an elastic limit, the material can regain back its shape, but maybe not fully like that. Yes. But when it gets to yield point, it can't regain back its shape. Then breaking point, the material will spoil. Now, I have just summarized the whole class. The last part of this summary is your work done on a spring, which I said finally is half Fe or half Ke squared. Let us look at a question briefly. Now, let's say we have, I believe you should be writing this question so that you can go in line with me. Now, let's have a question like, a force of 0.8 Newton stretches an elastic spring by 2 centimeters. A force of 0.8 Newton stretches an elastic spring by 2 centimeters. Find the elastic constant. That is the question that follows. Find the elastic constant. Now, when you are given a question, what you should do is bring out the data you have from that question. Then it will enable you know what to do. Now, we have a force of 0.8 Newton there. 0.8 Newton is our force. And then we have the extension. The material was stretched by 2 centimeters. This is E, 2 centimeters. Of course, you should also have in mind that there will be a conversion, because when we have something like this, when we have F is equal to Ke, let me do this quickly. When we divide both sides by E, for example, I'm trying to make K subject of the formula. So K will be equal to F over E. The unit of this elastic constant is in Newton per meter. Now you are given this extension in centimeter, definitely you convert to meter. Now, converting this to meter simply means you should say, of course, 100 centimeter is equal to 1 meters. Now we'll divide this by 100, which will give us 0.02 meters. That is the extension. Now what you are asked to calculate is the elastic constant. The elastic constant is K. When you find out this, you discover that K is equal to F over E. If you have K to be equal to F over E, we have F as 0.8 Newton. Now K is equal to 0.8 over 0.02. If you punch your calculator on that regard, you will discover that your answer will be equal to 40. 40 what? 40 Newton per meters. And you are done with such a question. Now, let us look at one more question briefly before I hang it up from here today. Now, we have a question like this. Listen carefully. A stone of mass 5 grams is projected with a rubber catapult. If the catapult is stretched through a distance of 7 centimeters by an average force of 70 Newton, calculate the instantaneous velocity of the stone when released. I repeat, a stone of mass 5 grams is projected with a rubber catapult. If the catapult is stretched through a distance of 7 centimeters, I beg your pardon, by an average force of 70 Newton, calculate the instantaneous velocity. Now, if you have done a topic known as work, energy, and power, if you have done a topic known as work, energy, and power, you will discover that we are going to be using some facts from there. Now, we already know that from this question, we have the following data as given. We have a force of 70 Newton. We also have an E extension of 7 centimeters. We also have a mass of 5 grams. I think these are the data that we have here. Mind you, from the question, they say by an average force. So whatever we're going to be doing, if we need to be using your formula for work done by a spring or a material, an elastic material, we are not going to be having that particular force. Now let's go. You are to calculate the velocity. This is when we are going to be using some facts from work, energy, and power. Now let's go. If we say W is equal to half FE, but I told you it's an average force that we are being asked, or we are being given rather. So we are going to be saying W is equal to FE only, because it's an average already. So we have 70 Newton. Mind you, we have 7 centimeters, which will convert as usual over 100, which will give us 0.07. Now 70 times 0.07 is what we are to be doing. Now we will have this work done by this spring to be equal to 70 times 0.07, which will be 4.9. 4.9 joules. That is unit for energy. Now this work done is an energy. Energy is also the same with the potential energy, because if we don't join potential energy and kinetic energy, we can't find that particular velocity. Now this is an energy which is energy stored in the string before it will be fired. Now you know that work done is the same thing as potential energy. Potential energy is equal to kinetic energy. Now work done is equal to half mv square also. Then if we do that, we already have this as 4.9, work done is 4.9, and then we have the mass given as 2 grams. The mass is 2 grams from the question. When we change that mass to kilogram, it will be 0.002 times v squared there. By the time we do this, if you work this out for the sake of our time, you will end up having your answers correctly. I've just given you a clue and a guideline on how to finalize that question. You can solve that question. You can respond via the social media handle, Facebook, Instagram, and Twitter. Thank you for being with us on the Eduradio program today. I remain your teacher, Bisala Vincent. Thank you very much.
Thank you very much, our teacher, our physics teacher, for that wonderful job. I remember when we were at secondary school, me and my friend, who we call John Black, Adode, Francis, Innocent Bernard, when they call for class or mathematics, they go say x2 plus this, find x. Where you keep them? You keep something, customer find out. You will keep and go find them. And if you find them, then you go find us. So for Eduradio, you see how our teacher, the flow, this is what we want. When our students know their onion, they can compete side by side. They can talk wherever they find themselves. They can be proud of themselves to say they come from Nigeria. But not be the type where you go say somebody graduates. You and I are living witnesses of some of our coppers today. The coppers are claimed that they don't graduate. Some of them, with due respect, we can't accommodate them somewhere. But when a child is well finished and well chromed, he or she gets the best. We urge our members to listen to us. For Eduradio, we no go stop. For Eduradio, make you like, make you share. For our Eduradio Twitter, you will get us for Eduradio at eduradio.ng. For YouTube, eduradio.ng. Follow us, like, subscribe, share. You can just be doing one favor to somebody with this somewhere. I want to appreciate our frontline health workers when they're out there to do their best. I want to appreciate you when they listen to us. You when they even call us. You when they criticize us. We are open to criticism. We are ready. That is the only way we can improve. Criticize us. Hit us. Whether constructive, anyhow you like them. Education. Our education is worth the while. And with you and I, we will soon come up with an educational summit where we're going to engage them. We will talk. Then we'll give examples. See you next time, same time next week, Tuesday, with Eduradio. I remain Oman Dave, and my very beautiful and very handsome crude men when they're behind the scene. God bless you all. Bashir and GM Joshua. Jesse. And my wonderful teacher here. God bless. I say, same time next week. Bye-bye.